Hello and welcome to this video for the AQA Computer Science Paper 1 Skeleton Programme for 2019. I'll be looking at the C# version of the programme, but you should find it useful whatever programming language you're planning to use. By now you should have had time to already look at the source code and to run through playing the actual game, and what I intend to do is to go through looking in detail at many of the subroutines within the program and explaining how some of the data structures are used. So jumping straight into things, we'll start off with the main function, and after declaring this string file name, you can see the first thing it does is to create a list, and this list is made up of this place data type. So the list is called places, but the data type is place. So what I'm going to do now is just jump out to the definition for this. And we can see that this is defined, at least in the C# version of the program, as a class. It's actually a pretty straightforward class. All it does is declare some data. We've got a string, we've got some integers, but there are no methods, there are no functions defined inside this class. So really it's just being used as the equivalent of a struct in C#. Looking at some of the other classes that are declared in this program, we've got this class called item, and again there are no methods, we've simply got some attributes defined for this class, so a couple of integers and a couple of strings for the item class. And moving on, we have the character class, and again no methods, just attributes, so these classes only contain data. So continuing with our code execution, we said we've got this list of places called places, we've got a list of the class called item called items, and we declare another list of characters using this class character. So now we've got the code outputting to the screen to enter a file name, and you can see that appended to whatever is read in with the console.readline, it puts the .gme. So this is automatically adding the extension to the file. So typically you'll type in flag1 or flag2 and it automatically puts the .gme on the end of, and then we've got file name there. And then it calls this subroutine load game, and it's passing to that the file name, but also these three lists that we've just created. So let's have a look at what this actually does in the load game subroutine. So you can see this is quite a big subroutine. What we're going to do is just zoom in and go through it and work our way down. So we're declaring some local variables at the start, number of characters, number of places, number of items. Recall that these are the parameters that were being passed in when we called it from the main subroutine. And we get to this line, using binary reader reader. So this is in effect creating a new binary reader called reader. It's going to open the file, and it's using the file name that we've passed in. As I say, this is likely to be flag1.gme or flag2.gme using file mode open. So it's opening the file so that we can read from the binary file. And then it calls reader.readInt32. So this is going to read a 32-bit integer from the file into this variable number of characters. Now, if you've looked at the data file that was supplied with the skeleton program, you might have seen that the first thing in that data file, if you look at it with a hex editor, is that we've got these 32 bits that make up a number, and the number represents how many characters are being stored in that file. So once we've read that in, we can now use that number of characters to work out how many times we need to iterate to read in one character at a time. This is what this bit of code is going to do here. So if, for instance, the first number in the file is 3, it's going to go around this loop 3 times to read in the details for 3 characters before moving on to the next set of data. So when it goes around this loop, you see the first thing it does is it makes this variable temp character. Now, its data type is character. If you recall, this was a class. So what we're actually doing, and you can see from the syntax it's using here, temp character equals new character, this is calling the constructor method for the character class. We're actually creating an object here called temp character. If we have a look, we can see this is the class for character. We can see it includes these data here, we've got a couple of strings and a couple of integers. So what we now need to do is to read those data in from the file and store them into this object that is of the class character. So we read in 32 bits to go into the ID, so that's going to go in there. We're going to read in next a string which goes into the name, and another string for the description, and another integer for the current location. Once we've done that, we've read all the details in for that character. We then, with our temp character object, we add that to the list of characters. So this is the list of characters that was passed in as a parameter earlier on. And then moving on, we can see we do something similar for the places. So again, we're reading a 32-bit integer, and that gives us a number of places that are stored in this file. These are the locations in the game. So once we've got that, we know how many times to iterate. It's going from 0, and while it's less than number of places. So if, for instance, there are 10 locations in the game, that would read 10, and it would go from 0 while it's less than 10, so from 0 to 9. And again, it does the same thing. It creates this kind of placeholder object, this temporary one. It reads in the data, and if we definition for place, we can see these are the data that are stored in this. So it's just reading them in sequence, the ID, description, and so on, storing them into the attributes of this temporary class, this temporary object, and then it places that object into the list of places. And again, this was the thing that was passed in as a parameter into this subroutine. And then looking slightly further down, we can see similar thing again. This is for the items that are stored in the game. So it reads in how many items are in the file, iterates the correct number of times, and it goes, and here's our item class, and we can see these are the attributes. It's reading them in from the file, putting them into this temporary object, and then adding the object to the list. You'll notice that we had a try catch in this subroutine. The try was just before this whole section, before it tries to open the file, and so the catch down here will catch any exception that was raised when dealing with the file. So if, for instance, the file doesn't exist, it would raise an exception which otherwise would generate a runtime error and cause a program to stop working. So if we've read in our file successfully with no errors, then it will return true. If, for instance, a file doesn't exist or for whatever reason it couldn't read it, it would return false. And so our code execution would now return to this point. We've just called load game, but notice it's inside this if else structure. So if load game was successful, and meaning it managed to open the file and read the details in and so on without any exceptions being raised, that returns true. So in effect we're saying if true, then it calls play game. If an exception was raised at any point during this subroutine, then that would return false, meaning it will go down the else branch, and that's when we get this error message here, unable to load game, and we wouldn't go any further. However, let's assume that we've managed to open the file, and we're now going to call the play game subroutine, and again we're passing the list of characters, the list of items, the list of places into that subroutine. So this is quite a big subroutine, although a lot of it is taken up by this big switch case statement. What we'll do is we'll look at it a little bit more closely, and we'll start from the... So working from the top, we can see again these parameters that were passed in. We're declaring some variables here. Stop game is one that we'll return to later. This is a boolean that gets initialized to false, and this controls when we should actually stop playing the game. A few others, instruction and command, moved, and result of open game. We'll look at those in a little bit more detail later. Let's firstly think about this one. Stop game gets initialized to false, and we've got this while not stop game. Okay, so until stop game gets set to true, we're going to keep on going around this big while loop. The first thing it checks then is if moved, meaning if this boolean variable here moved is true. Well, it is true at the moment. The first time round the loop, it's been initialized to true. So we're going to go into this branch here. So it's going to output a couple of blank lines, and then we get to this line here, console.writeLine places, and then we've got this big evaluation here in square brackets, and then we've got the dot description. So let's have a think about how this works in more detail. So the first thing to think about is places itself was this list, and it was a list of objects that are of this place class. Well, we can see that it's looking at one of the places that are in that list, and it's displaying the description attribute, but the square brackets notation here is telling us which index in that list to look at. But which place? How are we going to work this out? Let's have a look. Well, the elements in a list will start with 0, so that's the first index. And we're getting our index from this bit in the square brackets here. It's looking at characters 0 dot current location minus 1. Now, characters is our list of characters, and each character, as we can see, has a current location. So it's looking at the first character in the file. Now, character 0 is the player. This is you if you're playing the game, and your current location is where you've started off in the game. And we subtract 1 from that because indexing starts at 1 in the list. So what this is going to do is it's going to work out where you are at the start of the game, your current location, find that as an index into the places list, and then use WriteLine to display the description for that particular place. And so this is what we would expect to see. This is the actual description that it's pulled from the file, put into this places list, and now it's displaying that to the console window when we run the game. So moving on, the next line of code is this. We've got a call here to a function called display gettable items in location, and we can see it's passing our items list and it's passing our current location. Remember, character 0 is always the player, so it's passing your location at the start of the game into this subroutine. So let's look at this in more detail. So here we have the display gettable items in location subroutine. Again, notice the parameters that are being passed into it. So we've got the items list, and we've got your current location, and we've got a few local variables being set up here. So contains gettable items, boolean, initialized to false, and we've got this string here, list of items on the floor there is, and that's going to be added to if there's other items in this location, so we can display this. So let's get into this. We've got a for each loop here. This is looping through each item in this list of items, and this is basically going through each one, and then each one gets put into temporarily into this variable here called thing. Notice it doesn't give a data type for this. If you don't specify the data type, it will just basically work it out. So it's looping through each item in the list. Recall, this is the items class, so each time we get this thing here, thing has an ID, a location, and so on. And it checks each item to see if it's in the current location. It looks at the location of the thing that it's currently looking at in the list of things to see if it's the same location as where we currently are in the game. And it also checks if its status, that's this attribute here, contains the word gettable. The gettable attribute would be part of this string, and the string itself is basically a set of comma separated values that contain things like gettable and medium and various other keywords. So it's checking if gettable is somewhere inside that string. So as it's going through the list of items, if it is in the location, if it does contain gettable in its status, then it's going to go into this section of code here where in effect it wants to take the name of the current thing in the list of items and append it to list of items on the floor there is. So in the first location there's a couple of objects such as a torch, so it would say on the floor there is torch, and it sets the boolean contains gettable items that was initialized to false here, and it sets it to true. Now, there's one other thing that I've skipped here. If this was already set to true, it means it must have found the first gettable item. So what it does is it just appends an initial comma before the next one, and this is the way of making sure that the list of items that it displays has got commas between the list. So finally, once it's looped through all of the items in the list, it checks again if contains gettable items. That means it's found a single or one or more items in that location, in which case it outputs at the end of list of items a full stop. So it will say on the floor there is the list of items and a full stop at the end. If there's nothing in the room, it won't output anything. And we return back into the play game subroutine at this point, and then it sets moved to false. So next we've got a call to get instruction, which we can see is a function with a return value, which is going to get stored into this string variable here called instruction. So we know that this is a function that we're not passing any parameters to, but it's going to return a string. Let's see what it does. So this get instruction function will display a prompt. So it writes to the screen this prompt here. So it's going to do a /n is a new line character, so it's just going to display the angled bracket and a space, and then it's going to use console.readline, which is going to read in the user's command. It's going to convert it to lowercase, put it into instruction, and then that becomes the return value. So fairly straightforward. So for our example, what we'll do is we'll follow the execution of the code if we type in the command get torch. So this then gets read in, it gets converted to lower, which it is anyway, but if we'd written it all in uppercase or a mixture, it would get converted to the lowercase version anyway. That goes into instruction. That's now our return value. So when we return here, in this case, instruction would now contain the string get space torch. And our next line is to call extract command, and this is passing instruction to it, but notice it's passing it by reference. So any changes that get made to instruction inside this function will also be changed inside this copy of instruction that we're currently working with in this subroutine. So let's have a look at extract command, and we can see we're expecting that to return this variable command. So here we go, this is extract command. As expected, it's returning a string which is going to go into that variable called command, and we're passing a string by reference. So firstly, it checks if instruction contains a space. If not, this is what the exclamation mark, if instruction does not contain a space, then it returns instruction exactly as it is, and that's the end of the subroutine. So the purpose of this is to extract the command word from a longer instruction, and if it's just one word with no spaces, then the word is already the instruction, so we don't need to do anything else with it, which is why we're doing this first. So we then go into this while loop, assuming that our instruction has a space in it, meaning it's probably made up of more than one word. So it goes around this loop while instruction.length is greater than 0. So the length of our instruction is greater than 0, and the first character instruction does not equal space. So it's going to look at the first character and append that to this variable command. This is the thing that was initialized to an empty string at the start, and then it removes that first character from instruction. After removing it, you can see it gets assigned back into instruction. So it's basically going round and round in a loop, taking the first character and putting it into command and removing that character from instruction. We could look at this as an example here where we've used our get torch instruction. So this gets passed to it into the variable instruction, and the first time round our loop, length is greater than 0, and the first character in there does not equal a space. So it takes the first character from instruction, that's the G, and it's going to append it to command. And not only is it going to do that, it's going to remove that G from instruction and assign the result back to instruction. So what we end up with is command equal to G, and instruction has now lost its leading character, and it'll go around the loop again and do the same thing again because it still hasn't encountered a space. The length is greater than 0, goes around and does it again, removing the E, and then it will do it again, the T, and then the length is greater than 0, but it has found a space at this point, so it's not going to go around that loop. So at this point it's going to go into this while loop here. So instruction has had the get removed from it, so it now consists of a space followed by TORCH, and this final while loop here will remove any leading spaces. So it checks if the length is greater than 0 and if the first character equals a space, and if it does equal a space in that first character, then it removes that first character and goes round it again. So at the end, command will equal get without a space in front of, at the end of it, and instruction will equal torch, again with no spaces, and both values get returned to the calling program, the calling subroutine, because command gets returned as a return value and instruction was passed by reference, so the calling subroutine now has access to those new values for both of those. And having returned now from extract command, we've got our values for instruction and command. We go into this big switch case statement, looking at the value of command. So in this case, we've just called we've used the get torch command. So we're going to go into this branch of our case statement. Note the parameters then that are being passed. We're going to call get item, and again we're passing the list of items. We're calling instruction, which we've just been using in the last subroutine there, and we're passing the current location. Remember, character 0 is the player, so we're passing their current location. We're also passing this stop game boolean variable, and that's being passed as reference. There are no return values, but do bear in mind that if this gets changed in the subroutine, that change will be reflected where we are currently. So let's have a look at this get item subroutine. So here we are. This is another long function, and it makes lots of calls to other functions within it. So you can see the first thing it does, we're declaring a few variables here, which we'll look at some of these in more detail in a moment, but we go straight into then calling get index of item, and we're passing to that item to get, the value -1, and items. So let's see if we can work out what's happening inside this function. We also expect it to be returning a value which is going to go into this index of item. Well, the first thing we can work out is that item to get was actually passed into get item as a parameter, and when it was called, what was passed into it was the command and the instruction, and the instruction part of it gets stored into item to get. So the command was get, the instruction was torch, so we're actually passing the word torch into get index of item and this constant -1 and the list of all of the items. So let's have a look at get index of item. Right, so here we are, get index of item, and those values have now been passed into these local variables. We're expecting it to return an integer number. So after creating a couple of local variables here, it goes into this loop, and what we're doing is we're going to loop through each item. So while stop loop is false and the count is less than the number of items in this items list that was passed into it, we go around this loop, and if the name of an item is the same as item name to get, or the ID is the same as item ID to get, then stop loop gets set to true, and that will stop the loop. Otherwise, it will loop through all the items and stop loop would get set to false at the end. So if the item is found, it will return count. So this loops through the items. When it finds it, it sets this to true. Otherwise, it keeps incrementing count, and then it will return count if it found the item, or if it didn't find it, it will return -1. So in effect, it's gone through the list of items. When it's found it, that's the index of that item, which should be stored in count, and then it returns that. So when we've returned, the first thing it does is it checks if index of item is -1, meaning it couldn't find that item. So if we tried to get an item that doesn't exist, then it will return -1 and it will say you can't find. However, we tried to get the torch, which we know does exist. So now it goes into this else if here, and it looks to see if the item with the index, so that's the one in the list that we've found, if its location is the same as inventory. Now, we've not really looked at this yet, but at the start of the program, it declares some constants, and one of those constants, here we go, inventory, is 1001. So inventory is set as a constant 1001, so anything that has a location of inventory or of 1001 means you've actually got it, you are already holding that. So if neither of these two things are true, it then checks if the particular item that we've got in its commands attribute contains the string get. It's actually checking if it doesn't contain the word get, and if that's the case, then we get this message here, you can't get, and the name of the item that you're trying to get. Otherwise, we'll go into the else, and we've got another if statement here, and this is checking if the location of the item that we're trying to get is greater than or equal to this named constant minimum ID for item with a value of 2001. This means it's stored inside another item, and the location of the item it's stored in is not in the current location. So in that case, it will output you can't find that particular item. So it could well be an item that exists at this point, but it's not an item that you can currently get. And if our item then means it's an item that exists, that it's in the list, it's not inside another item, and it's not at another location, it must mean we can get it. So can get now gets set to true. So after checking all that, if can get is true, i.e. the item is in the current location, the item is gettable, and it's not an item that you already possess in your inventory, it calls get position of command, and it passes to it, this is the commands attribute of the item that we're trying to get, and it passes the string get to the subroutine. So let's look at this. So this is get position of command, the command list we pass to it, the string get we've passed to it, and it sets position to 0 and count to 0. And what we have is this while loop here, and it's changing the value of count, which was set to 0. It checks whether count is less than the length of the command list minus the length of the command being get that we passed to it. Each time around the loop, it creates a substring from command list that starts at the current character and has a length of the command that was passed as a parameter. In this case, the get command, which has a length of 3. So the loop can stop 3 characters from the end, which is why we've got the minus command length dot 3. Because if it hasn't found the command by then it mustn't be in the string. If the substring is in the command, it returns the position at which it found it. If the substring begins with a comma, the value of the position is increased by 1. The position in which the command in the list of the commands, not the position of the first letter indicated by the count. In this case, the get command that we're looking at here is in position 1 because counting starts at 0. So in effect, what this would do was to start here, it would take 3 characters. It would take USE. That's not the command that we're looking for here. So it will then add 1 to count, and it will look at SE comma. That's not it. E, comma, G, and so on. Okay, when it finds the comma, it adds 1 to position. So when it finds a comma there, position goes from 0 and then gets set to 1. And then the next substring it takes is get, get. That is equal to the command, so it returns position for position 1. So returning from get position of command, it's given us position 1. We now go straight into another function, get result for command, and this time we're passing the position along with the results attribute of the item, and we're expecting this to return this variable result for command. So let's look at this. So the point of this is that when you're given a command for a particular item, there's a results attribute for that particular item that contains the results of using the commands. So if we look at the torch that we're using the get command on, we can see that it's got 2 sets of results. The first one, the second one is it is easy to see now. Now you might be mistaken in thinking if you call use, this would be the result, and if you call get, this would be the result. That's not the case. The results for each of the commands are actually separated by semicolons. So we've actually only got 1 set of results here, which are for the use command on this particular item. So after initializing our variables, the code is now going to go into this loop where it's going to be looping with values of current position starting at 0 up to the value position, well, 1 less than position, which is the value of 1 that was passed as a parameter, where the 0 was for use and 1 was for get. It also checks that count has not reached the end of the results string, where this is our results string here. Every time a semicolon is found, so it's going through this results, and if it finds a semicolon, current position gets incremented. So current position is keeping track of how many different results it has counted so far, whilst count is the current character in this result string. So it's going through the string, and every time it finds a semicolon, it adds 1 to current position. And then once it's done that, when it's got to the end of the loop, any remaining characters are then concatenated onto the return value. So that's this loop here, where it continues with the current value of count and goes up to the end of the string, and if it equals a semicolon, it stops. It will jump out of the loop there, but otherwise it takes that character and concatenates it onto there and keeps on doing that, so it increments count until it gets up to the end of results. And then when we get to the end, this result for command becomes our return value. So for example, if the position is 2, then it will hope to find 2 semicolons in results before returning the remainder of the string. In our example of the get command, there are no semicolons in results. There are none there. So the first loop will keep going until count equals 27, which is the length of results. So the return value will be an empty string. So we would return from get result for command, and that will have returned an empty string into this variable here. And next we've got a call now to extract result for command. We can see this is a procedure. There's no return values. Note the parameters that are being passed, and we've got 2 parameters here that are being passed by reference, so we might expect something to be changed in the subroutine to these 2 variables here. Let's have a look. So this first while loop here is going through our string result for command that we've just received from our last subroutine call. So it's going through every character and it's extracting the character from there, and it's putting it into subcommand and going through each of the characters and adding it to subcommand until it reaches a comma. For our current command that we're doing with the get torch, it returned an empty string, so it's going to skip straight over this loop here, and then it's going to increment count and move on to the next character in the string, and again it will check that count is less than 0, which it isn't, so that in effect the procedure is going to end at this point because the result for command.length is 0. It's an empty string, and count isn't less than that, so that's going to be the end of our procedure call. If we'd used a different command and result for command actually contained a string, then it would copy every character into subcommand until it found a comma, and then any remaining characters up to the next comma or semicolon are going to be copied into subcommand parameter, and then both of these get passed back because they were passed in by reference. So we return from extract result for command. It checks if subcommand equals say, which in this case it doesn't. It checks if subcommand equals win, and again it doesn't. So then it looks at the item that we get in, it looks at its status and says, does it contain gettable? Here we go. Here's our item. Does it contain gettable? Well, we can see that it does. So because of that, it calls change location of item, and it's passing the list of items, it's passing the index of the item, i.e. the torch, and it passes the inventory constant. And the purpose of this is to move the torch from its current location to the location that it's going to be moved to. So it's moving it from where it is currently into our inventory so that we actually have picked it up and we own it. So this creates a new object, this item, based on the item class, which is a copy of the item that we're trying to move. It sets the location of our temporary item to new location, which is the parameter with a value of 1001 for our inventory that was passed into the subroutine, and then it takes this and it puts it into the list of items in the same location, in effect overwriting the original one. So if we now look at the item that we've just picked up, we can see its location has now been changed to 1001. And anything with a location of 1001 means it's in our inventory, we own it. So returning after our call to the subroutine, we go to this line and it's going to say you have got that. So looking at an update of what the console looks like, we've called get torch, and here's our output from that command. So we return back into this big switch case statement, which was in the big play game loop, and you can see the break command means it's going to drop out of the case statement. Now, as you can see, there's lots of other clauses in here which it would need to check, and some of these we'll return to later for looking at how other commands work. For now, we're going to scroll down to the end of it. So after carrying out the get command, that's the end of the case statement down here. But the case statement is inside a while loop, so we go back up to the 2 where the while loop is. So if you remember, we're inside this while loop here, while not stop game. So this loop's going to continue to read in our instructions. So it's going to keep on calling get instruction and extracting the commands from there, and then calling the correct command. So what we'll do next is we'll try a different instruction, and it will keep on going round this loop until stop game gets set to true. So if we carry on, I mean, we see that we haven't moved, so moved is going to be false, so we'll skip over this. It will call get instruction and we'll put in our next command. What we're going to try next is this command. We're going to try use torch and see how the code executes. So extract command gets called again just like before, and we'd expect this to return use, which gets stored into command, and torch, which would go into instruction, which was passed by reference, and remember it would strip the leading space from torch as well. We'd then go back into our switch case statement, and this time it's going to go into the use, which we'll call the use item function here. Note again parameters that are being passed, and the fact that stop game has to be passed into this by reference again. So you can see the use item function is quite a big subroutine. It needs to check if we can actually use the item that we're trying to use and then apply that command. So start at the top. After setting up some local variables here, we see that these are being initialized as well, it calls get index of item. Now you might recall that this looks through the list of items for the one that we want, which in this case is the torch, and it returns the index of that item. So it should find the torch in position 23 in the list, and it will check if the item can't be found, which would be -1 would be the return value, and if it can, it will then check if the item to be used is either in your inventory or the current location. So here it's checking if it's in your inventory or its location is where you currently are, and that the item itself is usable. If that's not the case, then the item can't be used. So if we've either got the item in our inventory or it's where we currently are and its status contains usable, then it calls get position of command. So let's look at this. So as we saw before, get position of command looks in this commands attribute here, and it will try to find, in our case, use in the list of commands. In this case it's in position 0, so that's what we'd expect it to be returning here. So then returning from there, the next thing we'll see is it calls get result for command. So this time round it's going to look in the results attribute, that's this string that you can see here, and it's going to look in position 0 of this string. Where I'm talking about positions, we're talking about strings that are separated by semicolons, which is what it's searching for. So what it does is it finds this string in position 0 and it will return that string as results for command here. So returning this result for command will now equal a string, say, comma, it is easier to see now. And this gets passed into extract result for command, which will extract, as we saw before, it will extract say into subcommand and the rest of the string, the it is easier to say now, into subcommand parameter. And then we'll move down to the if statement, and well, let's move down a bit to see what's going to happen next. So our subcommand was indeed say, so it's now going to call say, and subcommand parameter is being passed. This is the thing that had the value it is easier to see now. So let's see what the say function does with this. And we can see this is a really simple subroutine. It simply takes this string as a parameter and it outputs it to the screen with a blank line either side of it. And that's what the result would be. So after returning from this, you can see that because the subcommand was say, it's not going to go down this else branch or this else branch. So at this point we return and this function ends. And we return back to here. We've called use item and we return back into this part of the case statement. You see we've got the break here, which will drop us out of the switch command and back into our while loop, and this is the thing that now processes the commands, gets us to enter a new command and processes it. So we'll try a few other commands. So we can use the get command to pick up the other item that's in the room, the red die, and you can see that having processed that, it will say I have got that now. And what we'll do now is we're going to try use an open command. So when you read the description here, it mentions a couple of doors there. I'm going to try using the open yellow door command. And again, the get instruction subroutine will be called to get our instruction. Extract command will be called after, which command will have the part that says open, and instruction will have the other part which is yellow door. And scrolling down a bit into our case statement, we can see that if we've got a command of open, it's going to call this open close method here. Yeah, and again you can see a number of parameters being passed into it. The first one, true, is to indicate, because this command open close, you can see it's also used for close as well. So true will be called when we're using open, and false when we want to close the door. If you look at the call for close, you can see that false is the first parameter there for close, true for open. Let's move on then and have a look at what this is doing. So this is our function in question. As you can see, it's another big one. Let's look at it in more detail. So after setting up a few local variables, initializing some of these to blank strings, you see the first thing it does, it looks at this value open. This is the parameter that was being passed in with a value of true or false. So if true got passed in, well, it will go down this branch, command gets set to open. If we'd have called the one below in the case statement, calling it again, calling open close, but we pass false, then command would get set to close. But we're doing open yellow door, so command will now be set to open. So scrolling down a little bit, we can see that it goes into this while loop, and this is using count to go through each of the items in the items list. You see it also will jump out of this loop earlier as well if action works gets set to true. Further down we can't quite see it here. Count will get incremented. There's a count plus plus at the bottom of this loop. And so what we're doing is we look at each item in turn, and first of all we'll check if the name of the current item in the list matches the one that we're wanting to issue the command to. This is in this case the yellow door, which I know that in the items list our yellow door would be in position 2. It will then check if we've found it in our list, then it will check if that item is in our current location, so it won't let you open a door that isn't in the same room that you're in, for instance. It will then check the length of the command is greater than or equal to 4. This is a bit of a validation check that there's an open or close command on this. I think that's the only reason for checking a length of 4. In our case, the command list for our yellow door would be open, comma, close. It then checks that the commands for this particular item match the command that we're trying to issue. In which, in this case, it contains open. So the command list for our yellow door, once it's found, it will contain the word open. It then checks the status of the item matches the command. The status for a door can be open, it can be closed, it can be locked. So if the status is open and our command is open, then it returns -2. It means you can't open an open door, or if we've tried to close, you can't close a door whose status is closed. And then it will also check whether or not that door is locked. So having looked at our yellow door, we've worked out that it's in our location, it's got command length of greater than or equal to 4, so it's got possibly an open or close command in there. It contains the open command that we're after. The status of it isn't set to open, it isn't set to locked, so it's going to call get position of command. You might recall get position of command gets the position of the command substring in this commands attribute. So we're looking at for the item we've got here, this is the yellow door, and so it looks for the position of open within this string open close, which in this case, because they're separated by commas, it's in position 0. After we've gone through this, it's then calling get result for command, which looks in the results attribute and returns the result in position 0. So if we look at this, it's going to look in the results attribute in position 0, and these are separated by semicolons. It will return west, comma, 4. Extract result for command then extracts the west part of that into the first parameter, direction, and 4, the second part of this, goes into direction change. And the idea behind this is that from our current location now, that if we move in that direction west, then this should now lead us to location, so direction change, the location that it would move us to is location number 4. Change status of item is then called. This is a subroutine we haven't used yet. You can see we're passing the items list to it, and we're passing its new status, which is stored in the command. So when we call this, command actually becomes the status of the new item. So the door, its new status will be open. And here we can see the code for that. So new status will contain our command open, and so all it does is it sets that into the status. You can see it creates a temporary object based on the current item at the index where we found it. It sets its status, and then it puts those values for that temporary object back into the list in the same place. And after we return from change status of item, we'll notice that the status originally before that call was set to close, and now the status has been set to open. So this door now, this yellow door, now has a status of open. And carrying on, action works. This was set to false at the start of the function, gets set to true, and we go into this while loop here, and this counts through each of the locations. So it starts, we count to at 0, so it starts at location 0 and it stops at 7 in the flag1 file. The flag1 file has got 8 locations, so places.count, if we've opened flag1 as the file at the start of the program, will make us count from 0 to 7 to go through each of the 8 locations. And what it does is when it finds the current location, so when it looks at a place that has an ID of our current location, it then calls change location reference, and you can see it's passing the direction, which was west, and the direction change, which was 4. It's also passing the list of places. It's passing this count, and it's also passing this value false. So when we look at the code, we see the first thing that value false goes into this Boolean variable here called opposite. So firstly, it creates this place, and this is a copy of the current location where we are in the game, taken from the places list. Then we've got this series of if and if else statements. So in our case, we want direction equals west and not opposite, because we were false. So if we go down, we can see direction equals west and not opposite is this one here, and this results in the west attribute of this place gets set to this new location reference, which was passed in as a parameter. And finally, this temporary object, its values get copied back into the places list, into that same location. So the end result of this, we can see that the room that we're in now, the west attribute for this location, it's the one with ID 1 where we started off, has now been set to 4, meaning that from our location we can now go west and it will take us to location number 4. And having returned from change location reference, it will carry on in this big while loop that it was in, going through the rest of the locations in the places list until when it gets to position 3 for the flag 1 game where we're at the moment, it would come to the location with ID number 4. And if you remember, that is the adjoining location. When you go through the yellow door, you go into location number 4 now when you go west. Because that door is open, that means it should also now be possible to move from location 4 to move east back to our current location. So change location reference gets called again, and you can see for this location 4, it starts off with east being set to 0. That means if you're in this location before you'd open the door, you can't actually move east. But after the subroutine's been called, you can see it will update that to 1, meaning that it will now take you into location number 1 from the current location if you move east. It then gets the index of the other side of the door, which in this case would be 3 for the yellow door, and calls change status of item again. And this is to set the status of the yellow door so that from the other side in the other location it also gets changed from closed to open. Finally, it checks if action worked is true. If for whatever reason something failed, such as we were trying to open a door that was already open or something like that, then it would return -1 to indicate that. In this case, it returns the value of direction change, which earlier on we set to 4, so that's what gets returned. And we're back here again. We've just called open close. We've got our return value, and next it calls display open close message. So we said before it's going to return this value here of 4, and it passes that into here, and also this boolean value of true. So we can see again that boolean value again indicates whether it's an open or a close command. So the true is assigned to open command, meaning that this function call is for an open rather than a close command. And if we follow the logic down, it will call say. So result of open close greater than or equal to 0, open command true, so it calls say, passing the value you have opened it. You can see that if other parameters are passed into this, if for instance the door is locked or the door is already open, then it's going to output different results for this. And here we can see in the console window, here's our end result, then open yellow door, and that's what gets displayed to the console. And we'll return back to this point, and we're back into the big for loop. This time we'll go have another look at another command. We'll have a look at the go subroutine. So what I'm going to do is I'm going to move west first of all through that open door. So here's the go west command. So this time when we go around, it's going to go into the go part of the case statement, and it's going to call this go subroutine. This is passing a few parameters. The character in index 0 is going to be the player. The player is character 0 in that list of characters. It's also going to pass the instruction, which is west. And the location of the player, the character's current location, is stored at 1, so it looks at position 0 in the places list. So this is our go subroutine. It's another quite long one, but not that complicated. So let's look in more detail. So we set this boolean moved variable to true, and it goes into this big case statement, and it looks at the value of direction that was passed in as a parameter. Now in our case it's set to west, so let's scroll down to that. So it's going to look at the current place, and it's going to look at the west attribute. This was passed in as a parameter, and we can see that west has a value of 4. This is the value that was updated when we opened the yellow door earlier. It means that from our current location it's possible to move west to the location that has an ID of 4. A value of 0 means that you can't currently move in this direction. So the code is going to branch down the else path here. This u variable here, this is the parameter that was passed in as position 0 in the characters list, and the current place was the current location in the places list. So the west field has a value of 4. So the player now has their current location set to the location with an ID of 4. So it's moved us into this location. And after it's dropped out of the case statement, we can see that there's some code here that checks if moved has been set to false, if not moved. This would be the case if the player's tried to move in a direction that's not available, i.e., if the direction was set to 0. The Boolean value of moved then gets returned to indicate if the move in that direction was successful or not. And after calling that go subroutine, we're back into our for loop, and we'll go around the loop again. But this time round, when we come back up to the top, the moved Boolean variable will have been set to true. So this if statement here will go into here, and it's going to output the description of the location and the gettable items. So we just moved to a new location. So you can see now when it's going to, as it did at the start of the game, output the description for our current location and the items that are available in that location. And this is what we can see here. So we've got the description of our location, and you'll see that there are no gettable items. That's why it doesn't list any items. I'm now going to go west again. As there's no door to open, we should just be able to go straight in that direction without having to open a door first. We've done that, and looking at the description of this location, we can see that this time there's another character. It's sitting in a chair. We've got a guard, so we've got another character in this room. So the final thing I want to demonstrate in this video is the play dice command. So to use this, we have to enter the command play dice followed by the character. So we're going to enter play dice guard. So following the usual logic, it will extract the command, and the case statement in the main loop is going to go down here, and it's going to call play dice game, and this passes to it the list of the characters, the list of the items, and the instruction part of the command. So we've got play dice as the command, and the instruction part is guard. And this is our code for play dice game. Let's look at it a bit closer. The first thing to say is don't be too alarmed looking at this. It's not a particularly long subroutine, but because we've got some quite long lines of code, the text wrapping is causing it to look a little bit untidy because we've got some long variable names and so on. So firstly, we've got some local variables being set up here and being initialized to 0, and we'll look at these in a bit more detail later where we need to. The first code that's executed is this call to check if dice game possible. That's on this line here, and you can see it returns this Boolean variable here, which will be referred to later. This is going to return, a true or false value, and you can see that again a lot of parameters are being passed, and 3 of these are being passed by reference. So again, we've set up a few variables, initialized all of them to false, and then we're going into this loop here. So this is looping through each item in the list of items. What this is doing is it's checking 2 things: that there's an item that's in your inventory, and that the same item has die in the name, i.e. that you're holding a die, because you can't play the dice game unless you've got at least 1 die. If it finds such an item, i.e. a die that you are actually holding, then player has die gets set to true, and then we call get index of item, and the index of your die is found, and that gets returned into index of player die. Moving down a bit, after initializing count to 1, you can see this while loop then loops through each character in the character list, whilst players in same room, this Boolean, is still false. It checks if the location of the player, i.e. that's the character in position 0, the player, is the same as the location of the current character that it's looking at in the list of characters, and that the name of the character it's looking at in the list of the character is the one that was being passed as a parameter, i.e. it's looking to see if there's a character whose name is guard that has the same location as you, the player. And if that's the case, it sets players in same room to true, and then it goes into another loop. So in this loop, again, we're looking at all of the items in the item list. This time it's now checking that there's an item that has a location that's the same as the guard's location, and that particular item, it has a name that contains the word die, i.e. it's checking if the guard is actually carrying a die. So by this point we're checking if the player has got a die and if the guard has got a die. If so, it gets the index of the guard's die and sets the index of other character, that's this one, the guard, to count. It's gone through the list, and wherever it's got to, that's now got the index of the guard. So we've now stored the position of the guard's die in the item list and the position of the guard in the characters list. The return value is quite interesting. This uses a Boolean AND here. So it's doing it on 3 variables. So in effect, all 3 of these need to be set to true for it to return a true. For anything else, if either of these are set to false, because it's using a Boolean AND, it would return false. So in our case, we know that we've got a die. We know that the guard, if you look at the file, you'll see that the guard has a die. So all 3 of these should be set to true. So this should in fact return true. And we return here, and with our call here, it returns true, and so dice game possible will have been set true as the guard in the room is carrying a die. So we've got an initial check here of that, and it's going to go into the else branch. If any of those other things in the last check had returned false, this is what it would be displaying if, for instance, we didn't hold a die. But it's not, so it's going to go down to this else branch. We've got a call to get position of command. This finds the position of use in the list of commands for the player's die. So as you're playing it, you've got your die. This is using this index, and it finds the position of the use command in there. The commands for this are use and get. So because use is the first one, it would return 0. It then calls get result for command, which we've looked at already. In this case, it returns roll, 1, 1. Then this gets passed into roll die. We can see from this illustration that when we're calling it now, we said we've got roll, 1, 1, and it's passing the character at position 5 and the character at position 7, which both have a value of 1. So let's work out what the significance of those two 1s are. When we call roll die, it passed a 1 and a 1, which it got from the properties for our particular die. You can see they're going into these variables here, lower and upper. Well, it sets lower limit value to 0, and then it uses try parse to try and convert lower into an integer, which will then be stored in lower limit value. If it's not successful, then it gets a user to enter a minimum value here, and it will stay in a loop until they enter a value between 1 and 6. It then further down does the same for the upper limits. So you can see what it's done is those lower and upper limits, it basically checks that it can put those into integers. If it can, it will get you to enter a number, and then it calls get random number. So we've called this subroutine get random number, and we've passed this lower limit value 1 into this variable also called lower limit value, and upper limit value, which was also 1. And what this does is it just generates a random number between those two limits, and then returns the value. So for our die that we currently have, it's going to generate a random number between 1 and return that value. So player score now contains the value that was generated, and for the die that we have, the lower and upper limit are both 1, so the score will always be 1. If we want to do well at this game, we're going to have to find a better die. After outputting the player's score then, so you rolled a, it's going to tell us what we scored, then it does the same thing for the guard, so it will do the same thing with the guard's dice. This is the character that we're playing against. In our case, it's the guard at the moment. Now the guard's got a much better dice. He's got a lower limit of 1 and an upper limit of 6, and again, if you look at the data file, you'll be able to see this. So if we look at the output of our program now, unsurprisingly, the guard with their better dice has won. After outputting who rolled what score, we've got an if statement here, and this checks who has the highest score, or indeed if it's a draw. If you've won, it will call take item from other character, and it will pass the list of items and the ID of the character that you're going to take an item from, the character that you might have just beaten. So if we had won the dice game, it would be calling this now and passing the guard's details. It starts off by creating a couple of lists here, which are going to store the index and the name of all of the items in the inventory of the other character, the one that we've just beaten. It then loops through the items, in the list of items, and when it finds one that's in the inventory of the other character, it adds that name and index to these two new lists here. It then outputs the lists of names and the items, and the user can enter which one they want. So it outputs them all and asks which one do they actually want. So when the user has entered the name of the item that they want to take, it checks whether the list of names of items in inventory contains the name of that item that they've typed in, and then it calls change location of item here, and it passes a list of items, the index of the item to be taken, and the constant that represents the player's inventory, 1001. And finally, it's worth noting that if they've entered an item that the other player doesn't have, that wasn't placed into this list, it will go down here and tell you that they don't have this item, so you can't take anything. So if we'd won our game of dice, well, we'd return here. But with the dice that we've got, it's more likely, isn't it, that we would have lost. In which case, it's going to say you lose, and it's going to call this take random item from player, and this again passes the list of items and the ID of the other character. So this again creates a new list, but this one will store the items in the player's inventory, and it loops through each of the items, and if its location is the same as your inventory, that constant with a value of 1001, it adds the index of that item to the list. It then generates a random number between 0 and the number of items that you have -1. This represents the position of the item in that list of indices here, and it will output which item they've taken. So they have taken your, and it will output the name of the item, and finally it moves that item to, by calling change location of item, moves that item to the new location, and its new location is the ID of the other character, which represents their inventory. And going back to our dice game, the final else here would be if it was a draw, but in our case we didn't stand much chance of that, having only rolled a 1. So looking at our game, you can see we rolled a 1, they rolled a 3, it says they lost, and the guard has now taken our torch. And you'll see that after calling that, we drop out of the case statement and we're back into our for loop, and we go around again to enter another command. Finally, I just want to take a look at how you can actually win the game. To do this, you have to get a specific item. We're looking at the section of code in the get item subroutine just after it checks if the item's available to be picked up. If the result for the get command on that item is win, then you can see that it will say you've won the game, and stop game gets set to true. And this will make that main program loop in play game terminate and end the game. So which item do we need to find that has a subcommand of win? Well, in the list of items in position 13, we've got an item there called flag, and it's got a get command, so it's an item that we can pick up, and the result of the get command is win. This is how you win the game, by finding and getting the flag. All you have to do is find it. If you haven't played the game through to completion, what I suggest you do is have a look on YouTube. Someone's done a walkthrough showing you how to get all the way through the game. Finally, I hope you found this video useful, and the last thing to say is best of luck with your exam.